Alright, let's look at the homework 4.7, problem number 7. A piece of wire 20 meters long is cut into two pieces. One piece is bent into a square and the other is bent into a circle. Alright, and how much wire should be used for the square to maximize the total area? How much wire should be used for the square in order to minimize the total area? Alright, so let's do that. Alright, so let's say let x be the length of a side of the square. Alright, so which means that the area of the square would be x squared. So the total area A is going to be written in terms of x. So it's x squared. Alright. Then the rest of it, so it requires four sides. So it's a 20 minus 4x meter left for the circle. Right. So in order to find the area, we have to know the radius, and this is going to be equal to the circumference. It's going to be 2 pi r. All right. So which means that let's say I'm going to divide through by 2 pi, and it looks like r is going to be let's see, divide by 2, 10 over 2x over pi. Alright, so we have that. That's the radius of the circle. So the area is going to be pi r squared, which means that the pi radius is 10 minus 2x over pi squared. So squared. Alright, which can be simplified as let's see, you have x squared plus pi, then you have a pi square on the bottom, right? Then so we have to I'll probably leave this guy as it is, 10 minus 2x squared. Alright, then we can cancel pi on top and the pi, one of the pi on the bottom, so we get just this. You're gonna get let's see, this is going to be equal to x squared and plus 10 minus 2x squared over pi. Right? So you can see that this is just going to be a quadratic function, and leading coefficient is going to be so you're going to get 4x squared from here and x squared, so 5x squared. So it's going to be a facing up parabola. Right? So we know that where the minimum is going to occur, the minimum is going to occur at the critical number, and the maximum will be either endpoint. Right? So what would be the endpoint? Is there any restriction on x value? Right? So there's no reason to, maybe we can just use all of the wire just for the circle, so x could be 0. So you don't use any for the square. Or we can use all of the wire just for the square, which means that let's see, we use all 20 meter so we need 4 pieces. So 5. So between 0 to 5. Alright, so we want to maximize and to minimize that, but we know that the maximum is going to occur at either at 0 or 5, and then the minimum is going to occur at the critical number. So let's take the derivative. Oops. Alright, derivative of this is going to be 2x, and derivative of that, it's let's see, over pi, just a constant, and put 2 in front, and 10 minus 2x, and then multiply by negative 2, which is a derivative inside with negative, whoops, right, negative 2. Right, I'm gonna actually plug it in. Okay, let's see, so you're gonna get this, All right, this is going to be 2x plus, all right, here is actually it's going to be minus 2 times 2, 4. Actually, there's this both has 2 in it, so I'm going to pull another 2 out. So 4 negative 8, and then you have a 5 minus x, and over pi, and this we set this guy equal to 0. All right, and then we're gonna just divide through by 2. So divide through by 2, we get x minus 4 times 5 minus x over pi is equal to 0. All right. Then I can multiply through by pi. You get the pi x minus 4, 5 minus x equals 0. So what's this? This is going to give us, all right, pi x minus plus 4. So it's a pi plus 4 x minus 20 equal to 0. Right, which means that x is equal to 20 over pi plus 4. Right, so this is a critical number, and let's see. So we want to. So this is going to be at. So this is going to be give you the minimum. So let's answer that first. All right, how much should be used? So it's going to be 20 pi over pi plus 4. All right. But for the maximum, and we use either all of it for the square or all of it for the circle. And we have a feeling that the circle is a little bit more efficient in terms of covering the more area. So it's probably you want to use all the wire for the circle. But let's try. All right. So this means that so we have to look at the v of 0. Right, so that means that we're not using any for the square, all for the circle. So you're going to have, let's see, where's the equation? Here. So x equals 0. So I'm looking at this guy and plugging x equals 0 here. Right, so you have a 0 here, so it's a 10 squared. So you're going to get the 100 over pi. Right, so that's what you get when you use all just all circle, and just all squared would be use 5, right? That means 5 times 5 is 25, right? So you can see that at x equals 0, which means that you are using all for the circle. So this is going to give us the maximum. Oops. So this guy is our maximum. All right, so so which means that here, how much to find the maximize the total area? X should be 0. All right, so let's check the answer. All right, I came back and actually I messed it up because how much wire should be used for the square? So I have to multiply by 4. So instead of having 20 over pi plus 4, this should have been 80 because you have to multiply because you have full size, and that should be there. So let's check this answer. All right, it came back, and that we got both of these guys correctly. All right, that's it. I hope that this was clear.